Oh, hold on. Yeah. Okay, we are recording right now.
Okay, good evening, everyone. This is Linesh Dave, and with me is Yelena, and we'll be going over the assignment one text analysis today. So, and before we start, just want to make sure that you're all able to see my screen. So, have we all muted everyone, Yelena, or do you want me to do that?
Go ahead, do that.
I
Go
can see
ahead.
your screen.
Okay. Okay. Excellent. All right. As long as we are okay with, and I just want to keep it interactive. So as long as there's no background noise, we should be okay to keep it this way. And so I'll just set the expectations first before we go into the middle of the presentation here. So the main purpose of this WebEx or this webinar is to kind of just go over some of the steps that you already seen in the Word document. So, but at least just kind of trying to help you with how you would want to kind of learn and kind of apply the knowledge and how you want to expand on an example that's been given to you and in at least going through the data sets and also try to address any of your technical difficulties that you may be facing while going through the actual assignment, which is part two. So what you kind of see is just the part one here, but we try to kind of expand it, kind of show to you what, and some of the things that you could do and how you'd want to expand it. Okay. So basically the agenda would be, just to go over some tips for success, like how you could be, successful in completing your assignments, this course in general, and also kind of make sure that you're kind of going to be prepared for the next course, which is almost towards the end of your degree. So just want to make sure that you have all the tool set that you need. You have all the techniques and the abilities that you need for taking it to the next level when you go to the next course. The next step is the second in the agenda is our environment. I know Yelena sometime back had kind of given some nice presentation on our environment, and I've just taken some parts of that and just kind of sharing with you because I know that there's some kind of had to go through some challenges and some struggles in terms of hello. Folks, if you're not talking on the microphone, then please go on mute. I don't want you to mute everyone. Keep this interactive, but if we get some background noise, then we'll have to do that. Appreciate it. So there's a button out there, and you can go on mute. Okay. Thank you. All right. So next, we'll go on to assignment one steps, and just going through some of the steps that you've already seen. And just to kind of, maybe we'll go a little more details or maybe just see see if you have any questions. Then we'll go through some Q&A and just wrap up. Okay. So the time that we'll spend together here today is going to be more on seeing as to how you could expand and what you could do with text analysis, which may not be new to many of you. You may have done it before. With using certain tools, now we are doing it through R, and you'll be doing it a lot more during this course as this is based on the unstructured data, and we'll be, you'll be doing a lot more on this. So I think this is a nice starting point, but at the same time, want to make sure that you take this to the next level, right? I mean, it's not just to mimic what was kind of given on the part one, but you kind of take that as just as a base for what you could do and what are the things you can explore. Okay, so some tips for success. As Helena had kind of last time, Professor Gorcheva kind of had mentioned, that I'm I'm one of the students of this program and being a student, and so one of the products of this program. And so I just wanted to share, some some tips here that has helped me and also helped some of the folks who with me had graduated from this program. So number one, I would say practice with different types of data sets. It's not just trying to use the data set that are kind of not with too many rows in there, or maybe that have been used multiple times, or you have used in the past. I would say not go into that kind of temptation of using the same data set if you have used it before. Try different data sets. That will really help you to be more confident in dealing with any kind of modeling or any kind of data set that you have on hand. Second, and the most importantly, know the tools, right? I mean, I know some of you may have a good programming background, and some may not. But this is it's going to be important that we all learn and at least some of the tools that are going to be required. And some of you may think that, hey, if I'm a data scientist, I really don't have to program. I'll be using some of those sophisticated tools. I know some of you have already used SAS Enterprise Miner, maybe, and maybe many other tools along the way, and think that, I just put something in. Because you've seen in Watson Analytics, right? You take the data set, you put it in, and boom, it comes up with all the different things for us. It does all the display for us. Well, yes, we could be doing that in future. There are so many tools coming out, but at the same time, I think as a data analytics person, as someone who is going through this program or is graduating from this program, I want to make sure that we understand why some of the results we are getting based on the data set. What type of model are we getting? Why did we get the model? What kind of data set? How do you want to clean the data set? How do you want to have all these different visuals from this data set? That's going to be very important, and for that we'll still have to understand some of the nuances and understand maybe and have some of those some of the programming skills that may be required, right? So know the tools so that you can go in depth, right? And then you can help yourself in doing all those different tasks that are required in the process. So there's the help feature there. Anything that you take up, I mean, whether it's R programming, whether you are a Python lover and would like to do things in Python, or any other, and maybe Scala, or whatever you would have done in whatever you're working on, and maybe at your workplace, just there's always help feature. So make use of help feature. Don't give up. I mean, there's so much out there, and for R, there's a huge community. I mean, there's tons and tons of things that are available on the internet, and besides, as I said, there's so many blogs, so many internets, and plus there's a lot of documentation that's available. Make use of that. Spend some time with it, and that's really going to help you. I understand your struggle. I understand your challenges. Trust me, I empathize with you, and I've been through it myself. But these are some of the things that has really helped me, helped my fellow classmates and others that I've heard, who've kind of started with R or any of those programming languages. Because one of the simplest, languages and tools, and because of the fact that there's got so much out there, and so many resources and so much help out there. So take it as a challenge, or take it as something that you would be doing in future, or maybe today it's art, maybe tomorrow it could be something else, but you still have to gain those skills. So just get on with it, okay? And don't be satisfied with any bare minimum that's expected. If you've seen part one with only those different steps, you want to kind of just add some more to it. I mean, that's just a base. The whole purpose of putting that part one is to first give you some introduction, getting to kind of if you've not done much into text analytics, or if you've done it in some time back, it's just kind of a refresher on text now. What are the different steps that you would do? But is that all? Absolutely not. There's so much that you can add on to it. And even today, if you get a chance to kind of show you that there are things that you can do things in little different ways, and you can see maybe get a different visual, maybe get a different model, maybe you can get a better model, or maybe not. Even if you do not get it, you will want to know why you did not get a good model, why you did not succeed, and that's also going to be very important for us as data scientist, data analytics person. Every result is going to be important because we really want to know why certain thing really was successful and why something was really not successful. So just try as much as you can until you really have to submit your assignment. I know it's important. I know that last weekend is always going to be important, and we'll be doing a lot during that last weekend. But don't just wait for that last weekend. Get started right away. Get started and keep working on it. Even if you think you are done, fine, very good. Maybe that's giving you some more time to explore. Okay. Next, I just mentioned that read on the internet for problems, issues, new features, new techniques. There's always every other day you'll see a new package that's coming out for R. Same thing for Python. I mean, these are and many of the tools that if you're big fan of all the different tools that are out there in the market, there's always new coming out. I'm just going to one a seminar tomorrow for one of the tools that Cloudera just rated as number 5, and as I'm really excited. But as I said, there's always something that's out there. There's something new to learn, either it's technique, it's feature, or a tool. And so just keep reading on it. I mean, there's some material that is always is part of your course. I would suggest that you seriously read through it, because there's a reason why there's all those reading material has been posted for each and every week, because that's kind of adding on to a lot, and then that kind of is also helping you build that habit of reading some of the stuff, because this is an ocean, guys. I mean, there's a lot. Trust me, even after the going through these courses, you'll be still scratching the surface and say, oh my God, there's so much more to learn, and so much, because there's only so much you can do within the 12 to 15 weeks of your coursework. But as much as you can expand, that's good for you. You'll have a good base to kind of take this further. And that's what this is all about, to kind of build that base in a very safe environment. This is a very safe learning environment, so make use of it. You get access to these tools, and you get the time to put on. I think just take advantage of that. Build good programming habits. Okay, that's another thing that I want to really stress on. Build good programming habits. I just give you a link there. And I'll share this document with you guys. But the standard conventions, there are some standards that are also there as part of our programming. So use those standards. Use sections. Put up a template of steps for any problem solving. If you think that you're going to solve your problem in 10 different steps, put those steps. Just comment out and just put 10 lines in there, 10 sections in your code, and so okay, these are the things I'm going to do. Maybe data cleaning, data visualization, data modeling, maybe, and then conclusion. Whatever steps you can think of, put it in your code and put up a template there, and start filling in those sections. Start filling in that template. Okay, and then you can jump between those sections. I mean, even in R, there's a way to even include sections. So use the power of R. Use the power of R Studio. That can really help you, and also this would be really good for your programming skills as well. So build those good programming habits, and it will not just give a lot of clarity to your code, but it will also give you clarity in many ways. Let me tell you, after a few months, if you're going to look at your code, and if it is not written in a nice format, in a nice way, and nicely commented, you're not going to know what you did. Trust me. And this is for, and if you guys have been already doing programming, you know what I'm talking about, right? It's so important. So make sure that you're doing that. I'm sorry, just a second. So just having said that, just wanted to set this up with making sure that you kind of going through and following this. Okay. All right. So next want to just go on to the R environment setup, and I know that as I mentioned that there was some struggle, especially with the installation. So the first and foremost, you want to make sure that you have the right version of R and R Studio. Um, if it is for R Studio, I would suggest that just take a look at your R, what the version is. Even in the R Studio, you can just do like an about R Studio, and it will give you a version. If you are more than 0.99, I think you've got the latest version. I think it's 1.0 something, and it's the latest version. That will give you most of the the advanced features of R Studio. In terms of R, you want to be at 3.3.2, right? So it says your major is 3, minor is 3.2. So that's kind of saying that 3.2. Okay, that's the version that you want to get onto, which is the latest version, and all the packages. Okay, that also. So that two different ways. There's version. If you say R dot version, it gives you one particular there's a I think result set which is little limited. There's another way of doing it is R dot capital V and version, and it's like a method. So when you click on it, it will give you like a long list of things. So here you see that it gives you a lot more information than the previous one. Okay, so that's step one. Start with whether you have the right version. Next, and if you want to just check with all the packages that are available on CRAN, there's a way that you can you can just do a browse URL and give this particular link. It will give you all the available packages by date, right? I mean, and there's the all the list of things that you can do. So there's a link that you can go there, and if you get time, you can just kind of go over that. But in the interest of time, I'll just kind of keep going. But this is all the different packages, and I don't I'm not kind of suggesting that you go through each and every package. There's thousands of packages, right? But just in case you would be curious to know about certain packages, certain area, or a certain package that you may have heard or read in an article, this is the place that you would want to go and look for more information. Look for all the packages that are installed locally, right? It's important that this is another important step. I mean, there are ways to look at all the packages that you have in your R environment. There are also ways to kind of update it, and we'll go next on that. But yeah, you can just type in library and along with the parenthesis like a method on your console, right? On your console, just type in library and open and close parenthesis. It will give you like it will open up a new window, and it will show you all the different packages that are in your environment. Like as you see in here in this my screen here, this particular window came up with all the different packages that were there, starting in an alphabetical order, right? There's another command here, and this is also kind of giving you like a package view. More than the library, it's kind of just giving you all the different packages. It's kind of as I said, it's prefixed with all the package and the library names, but it's kind of giving you all this information here. It is if you use the search command. Okay. All right. Then if you want to install and load packages, so if you want to just load it in your environment, you would want to kind of use the library command. But now, before that, you would want to install it, right? So what is the difference between installing and loading? Installing this is something like it's not in your environment. Like your R Studio does not have a particular package. Your R environment does not have that package, does not have that library. So you are going to grab it, and you're going to grab it from the CRAN area, and you are going to install it locally. So once you install it, you would not need it over again. It's like you buy a new software somewhere, and you kind of install it on your laptop, and every time you want to use it, you don't go keep installing it, right? Like for example, if you use if you bring a Microsoft Office package, you install it once, and then you want to keep using it, You just click on it and you start the Microsoft Word or you start Microsoft Excel. You just start the program. You don't keep installing it. So that's the difference. That's the analogy I can use here. Installing is when you got a new software, you install it. Same thing here. You want a package that is not available for you in your environment, you install it. And one of the so here's the command here: install.packages. And let's say in this case it was text mining. So you have a TM package, and you want to just add dependencies. Now I know by default the latest versions of 3.3 is already using in terms of looking for dependency and still installing it. But there is still one flag that dependency is equal to true adds on, and that is it also looks for any suggestions. It says, oh, okay, so if you're installing TM, let me suggest that you also have this package, and that those suggestions are also coming in as installs. So you may be installing only TM package, but along with it, maybe there are 3 or 4 or 5 other packages that may get installed because they're part of that. There's a dependency. There's also a suggested that because you are installing this, you may want to also install the latest version of another package. So that happens with this particular flag. And then once you've done that, you want to use it in your program, you just use the library command. Okay, so that's the difference between library and the install and the library. Now you want to load it. For loading purposes, you use library command, and there's also another command called require. So you could say, okay, require, and it says, if there's a package name, if you give a right package name, it will just load it in your environment. If not, it just returns. If there's a subtle difference between the two. Library command, when it fails, it's a failure. It's a complete failure. But a require is just returning a warning saying, okay, I know you required a particular package, we don't have it. And so it's kind of just shown here on this window here. I ran a command, library no package. Look at the error. You look at the second statement here. It says error in library no package. There is no package called. Okay, so it's kind of giving me an error. And look at the next statement, require no package. Now in this case it says loading required package no package and warning message. You see the difference? So one is leading to an error, the other is leading to just a warning. And return is mostly used in methods when you're trying to the require is used in certain methods that you would want to just see whether you want to continue working on and not kind of just lead to an error situation. So many times during a programming, maybe you would use it as part of your code at times. But library is something that you want to do it upfront and make sure that something is loaded. If you want to really make sure that the package is definitely going to be loaded before you run other commands, then you want to go for the library command here. Okay, guys, and a couple more things, and then I'll kind of open up for your questions. So I'm not just going to keep going here, and there's also make sure that there's we have this two-way dialogue here. So I'm kind of halfway. Okay, let me do that. Let me open it up here very quickly in case there's anything that you want to ask or any questions on what we have gone through so far. Okay. All right. So knowing more about packages. So there's different ways. Once again, there are different ways to know more about packages. So one of the ways is to, as I said, the simplest of all is the help. Library help is equal to TM. That's one way. And then the other way is, so you could say, okay, I want all the information about TM, right? So it just, and as soon as you type in, it brings up a new window, and it will start giving you all the information here. And you can just go in and then look at this. Right? Then there's another way, which is a display. So you just type in the vignette TM command on your console, and it will open up based on your your settings, it would open up a window or a PDF file with the information of the TM package. And then there's another option, which is Vignette display on a browser. So you say browse Vignette TM, and it opens the web page with the links to examples. So these are three different ways, and also there's one more. I would just say that if you ever want to know very quickly about a particular command, just type in a single question mark, at the end in your console. Just say okay slash question mark about, let's say, cluster, or like k-means. Okay, so question mark k-means, and it will give you all the information about k-means command, right? It will give you information about how the command is, what are the different parameters, what does each parameter mean, and what is the output. I'm sure many of you would have already done this and then before in the previous classes, but just as a refresher, and if you've not done a lot of R programming, this is the best way to kind of get on with it, or to refresh about certain commands, about certain libraries. And so, as I said, this is always going to be a very good resource for you. Okay. And then package updates, very important, right? So yeah, it's one thing about installing it and forgetting about it and keep using it. The other thing is to make sure that you are getting all the updates that you need. There's so much. As I said, like there's so much community support to this couple of languages, especially R has been around for so long, and there's a huge community out there for R, and there's also a lot of support for this package development for R, that you would see that there are features being developed, or new features, and there's old features that are being updated. That's kind of going on. It's an ongoing basis. So maybe at times you want to check, if you want to really update a package, right? So there are a few options here. One is, you go to RStudio and you go to the tools menu, and there's an option called package check for package updates. As simple as that. You just click on and tools, and this particular menu option, you pick it up, and it will give you a list of all the packages that needs update. Simple. You don't even have to think, or you don't have to worry about which packages you have, which you do not have, and how many updates you want to give. Very simple. Just do this once. It will take a little time based on when was the last time you did it, but at least you will have everything done once. The other option is you go into the packages tab of the view panel, right? On the view panel on the right, you can check the boxes, like you see almost towards the bottom of your R screen on the bottom right. Usually, you have that viewer where you see all those plots and your the files, the file directory, all that viewer that is there at the bottom right of the RStudio. You would see a packages tab. You just click on that tab, and then it will show you a list of all the packages, all the libraries that are that you have in your environment. And all you need to do is just click on the update and check the boxes next to the name, and click on the update link. Just update is just right above that, right in that window. You just click on update. It will go and update. Only if you want just few of them, you can update only just few packages. There's one more option. You use an update command. You can give an update command for a specific package by providing a package name as an argument, or you can just all packages in the current environment. If you want to update it, you can just say update.packages, and it gets the most recent package versions. So this way, this is another like a programmatic way of updating all your packages. So there are a few ways you can update it, and none of them are really requiring any particular, there's no configuration parameters here, no confusing parameters. It's very simple steps to update all your packages. Okay. And then finally, you want to remove or unload your package, which, as I said, you would not need a lot, except there are times when you would need is when there's like a clash of certain packages, and you really want to make sure that you have the latest version, and that those are the times when you may need to remove it, or you may have to unload it. So unload and remove only if it is required. So when you use this command detach and comma unload is true, like this is just two parameters here with for the detach command, unloads the package from the current R library. So all it's doing, it's just unloading it, right? It's like saying, I was using Word, I don't want to use Word, I just close it, right? It's gone. It's no longer on your computer. It's not working on your computer anymore. That's what the detach is doing. It is just shutting down the program. Removing the package is like saying, I don't need Microsoft Office. I just don't need a Microsoft Word. I'm just going to remove this completely from my computer. I'm never going to use it, right? It's just using that analogy here again. It's just removing the package from your R environment. Okay? I don't know, guys, does this make sense? Does this really help? I mean, I hope maybe some of you already gone deep into our programming. Maybe this could be a little kind of repetition, but just kind of a refresher, because some of you may not have that programming background, or may have gone through some struggle because of the change of version. So we wanted to make sure that you kind of go back to a little bit of basics here, and make sure that you can you have the tools that you need to make sure that you have got the the right environment, and you can correct your environment. Okay. Any questions at this point? So we are moving on to our next agenda item here. So any questions? Please feel free to just chime in and just ask. I think this would be I think it would be best from this point on to have this session interactive rather than just one way, because as I said, this is not more of kind of talking about any assignment or text mining as such. It's about making sure that you have the everything that you need to kind of complete the part 2 of your assignment, and which is kind of due at the end of this week, or on Sunday to be precise. So part 1 was going to, it had all the different steps, and and there were some questions based on the steps that you were already that was already given in that Word document, right? So that was part 1, and part 2 was kind of taking up a similar data set and kind of trying to go through a similar step. So I hope part 1 you were able to, or I'm sure some of you were already done, or some of you were still into this part 1, which is good. I think even if you have gone through some struggle during a part 1, or you're still in part 1, I say that's okay, because it's good to kind of go through the struggle and learn it so well that you'll be able to kind of get on with it, and use this tool for many more assignments or data sets that you want to do it. So keep doing it, guys. I mean, and the more you pick it up, more resources that you can find yourself, or help yourself in a way that we just kind of showed you. Because as I said in the beginning of the session is all about trying to help you how to learn, right? That's the best thing we can do, because any time that we spend is not really going to justify what's the power of R, what's the power of there's so many packages out there. There are thousands of packages. We'll not be able to go through that, right? I mean, even if we spend few days with doing that. So the best is to look at what is available, what do you require, and how to use it, and if you run into problems, how to fix it, right? Or where to find solutions for. Okay. And of course, Yelena, I would be there to kind of help you as much as we can. But I think I understand that when you hit to a problem and it's 11 o'clock at night, 12 o'clock at night, and something's due, I know what you go through, right? So it's important that you have these techniques, and you know about these techniques to kind of fix things when you really need it. You don't want to kind of wait for a few hours to get a response back, or maybe wait for another day to get a response back and then fix it, because you may have lost some time, and most importantly, you may be in a frustrated mode that you did not make any progress. So these are some important tips, guys, and I hope this helps. And and able to go through this particular assignment and all the others as well. So so in this particular step, so we went through certain things here. In the first step was loading the text files, right? I mean, it's important to make sure that you load all the text files. And I know some of you had different machines, different structure, and different challenges you went through, but this is all exactly what you would face at work, guys. I mean, I'm telling you that if you had some struggle, some challenge, getting all these files into it, into a particular folder, you saw some different results than what was posted in the document, or what somebody else got it, or what your friend got. Exactly, that's what happens day to day, every day, because now somebody's environment is different, or some of these files could be coming in from a mainframe and you're putting it in a Unix box, or from somewhere to some other OS. This is exactly what the environment is out there, and it's good that we are facing it here and we are trying to understand it. Maybe the problem could be not as major as what you'd be at work, but at least you get to know some of these problems, and then you want to kind of know as to how to fix it, or what are some of the things, some of the techniques that you could apply, because you learn it here. I'm sure that it's going to help you with some of the major problems that you could hit at workplace. So loading the text files, I hope that was one of the easier steps because all the files were given to you, and all you have to do is just load the files, and then maybe make sure you are installing the R package TM. So in case you've not done this before in in R, you had to load the package, and there's a command that was given to you, install the packages, and all this kind of added here is a dependencies flag, which I just mentioned. Oh, I want to do that. If you have not done that, well, no issues. You haven't done anything wrong. If as long as your code has not showed that not given any warnings or errors, you are absolutely fine. As I said, this dependencies is just going to add, make sure that some of these suggestions, it's going to add on those suggested packages in your environment, or update the suggested packages. So I don't want you to kind of go back and just redo everything just because you do not have this flag initially when you install the package. Okay, so don't go back and redo it. But in future, if you are installing any of your packages, just see what are the different flags, and see what really makes sense. And that's why I said your best friend is the question mark. Install the packages in your console. Look for what are the different parameters. Anything that's out there, any command that you're using, because there could be so many different parameters that may be helpful. Maybe today's dependencies, and maybe you'd come up with some other flag. Maybe I may have overlooked, Yelena may have overlooked, and maybe many others would have overlooked, and you would find certain parameter that could be important, or maybe there's a brand new parameter that gets added up, and that's why going through and taking some help or reading the help documentation is also important. Setting the work directory. Okay, so now I said optional, guys. So now trying to make this a little bit interactive. This has been kind of going one way, so I'm going to ask a question here. Why do I say this is optional? I know in your exercise you have to do it, and you get the right result if you do it. So, but there are ways to maybe I don't know why I said it was optional. Can anyone answer this? Or try to answer? Come on, folks. I mean, as I said, this is a safe learning environment, and let's make this interactive. Or it doesn't have to be the directories. I know. Okay, let me go back to the chat environment. Okay. You can point to any directory directly. It doesn't have to be the work directory. Okay. Okay, John. So doesn't have to be that directory, right? But I just kind of said that if this step may not be required if our project is created for the assignment and all the required text files are placed in the R project directory. So now what happens is I don't know if you tried this, but if you create a project with an R, and so that directory where you create the project, that becomes your base directory. So in that case, if any file that's in there and you do like you just search for a file, it will be right there because that's taken as your base directory. Try this out. So once again, kind of just throwing things at you here and kind of just pointing to you some of the things that you want to kind of expand on and kind of keep. So any of your assignments, start with a project. See what's the power of project. What does a project do versus just running an R command, right? So try these different things that you could do it within R and see if that helps. So let me go back. Oops, sorry. Okay, so that's about these. That I said it was kind of optional, but if you're not using a project, you'll have to do it to make sure that you're going to that directory and you should be able to see all the files. I hope everybody has gone through this step at least and able to see I get the list of files and also loading the files into a corpus. So I hope there's no questions, but if there's any question, feel free to chime in, guys. Any questions up to this point? Okay.
Actually I do have a question.
Sure.
If we're using, let's say we want to use multiple URL resources versus text files, could we do that or no?
When you say you have multiple resources, meaning different types of files, like a PDF versus text TXT?
It says setting work directory, right? So can you do that to like a source location? Can you do multiple source file locations, or should we just do only the file for this?
Yeah, definitely you can do that. I mean, what this set command is doing is it's just kind of saying that I'm going to be lazy. I'm just setting it to that directory, and I'm not going to give any paths to that directory, and I'm just going to search for my files.
Okay.
As simple as that. But now if I want to, get files from 5 directories, I could still, go through my dir command, look at the 5 different directories, collect files from all 5 directories.
Oh, okay.
I could still do that as long as I give a path.
Perfect. Thank you.
So once you've got the files, right, it could be from one directory, and that was a good question, by the way. Thank you. If it is from one directory, or maybe multiple directories, and that happens, that scenario will definitely happen at when you are thinking about large systems where you have documents at multiple places. When you are, I'll give you an example, a very an example where you would also all agree that emails, right? If you would be if you would be really going through and analyzing emails, right, for whatever emails which are like or placed in multiple directories, right? Maybe user directories based on the users. They will all be in different directories, and there are so many different files. So you would need to know how you're going to grab those files and put it into a single corpus, right? So exactly. So you could just view all those different directories. Either you can copy files into one directory, or you have to link all those 5 directories and make it in a single corpus there after that. So you want to make a single corpus. So what's a corpus? Is basically taking in everything and putting it into in all your text information is placed in one area, the corpus. where you could now, kind of act on all the information at once rather than a file by file, right, in a sequential manner. You're doing it like almost parallelly to across all your documents at once for anything that you do on this, whether it's removing characters, removing, things, you're doing it across all these 18 files. So that's the beauty of, like, putting it in a corpus and doing it, because this is nothing new. I mean, programmatically, if you've been programming for a few years, or even now, you'd say, hey, I could do this in other programming language. I can just do it file by file. Yes, you could do that, and maybe faster or whatever. But this is the way to kind of just bringing things together and looking at it together, and then working on it right together. So that's like kind of, because now you're not just thinking of manipulating any information, you're also thinking of what that information is. You're also thinking about analyzing that information, and that's why having it together becomes so important. So anyway, so once you get the corpus, there's an inspect command that gives you all the information. This information is, I don't know if you guys looked at but you won't really want to look into in details here, because this is giving you a lot of information, and I'm going to give you a hint again. I know Professor Gorcha would be here; she wouldn't have liked it, but I'll give you a hint. There's something here that is going to be very important, and you are going to catch it. You are going to, and I hope you use it for your assignment, and it helps you in your assignment or whatever data set you're using. But I'm telling you, all this information here is important. If I were you, I mean, I would be just looking at it and making sure that I'm seeing what I really want to see here. I'm taking note of what is this metadata, how many characters. Well, I may not keep in mind all these numbers. Okay, I'm fine with that. I'm looking at the other information here. That's going to be important. Okay, so that's the reason for just looking at all this information, and also the different statistics, right? What is the length and the metadata of corpus, right? So this is something kind of an addition here is looking at the metadata of corpus. So what is metadata? It's kind of having some additional information for, either it's at the corpus level or it's at the document level. And it just kind of gives you an example here. So now, very similar to when you give like a length to your docs, which is a corpus, it gives you a length of, it gives you the number of documents. Similarly, if you give like, meta, at the corpus level, there isn't anything yet. I mean, so there's a data frame with 0 columns. Now, give the same thing like, when you look at the docs at the, so if it is in a document, if you look at the first document, it says it's a plain text document, and so this is how you would just point to the very first document. Now, once you have done that, just use the meta, so within meta, you just give the same document as an argument. Once you do that, look at this information that it gives you. It gives you an author, it gives you a date timestamp, description, heading, ID, language, origin. Now, for some of these information is characters, right? I mean, yeah, because you haven't really given any information. You haven't given any author information, then a description, any heading or ID. ID is it's by default. It just brings it with and puts in the name of the file as the ID. The date timestamp is also being plugged in there. The language is plugged in there. But the rest of the information is really it's blank. There's nothing out there. So it's up for grabs, really, if you think about it. So this is some way you can use it in future. I mean, this is metadata. So again, for any of your analysis or in a manipulation, you could be really using this data and see if not just read the data, but you can also update this data. Like you could just look at only one aspect, like date timestamp. Okay, so you look at the date timestamp, and it just gives you one piece of information. You can look at author. You can look at origin. So think about it. Programmatically, it has given you so much. I mean, it has some information additionally for each document that is out there that you can get. Now, same thing. You can not just get the information. You can also add or update the information. So that's the additional thing there. We can also add and update, and this is really very powerful, guys. And especially if you go into multiple documents analysis and then doing some more complex and going through some checks or things of that nature, this metadata is going to be really helpful. So keep in mind and just go over it one more time. Or if you have any questions, I can definitely answer that. So any questions on this? Does this make sense? I know for this particular assignment, it may not be helpful to you, or it may not make much sense. But overall, as I said, for text mining, text information, all this metadata kind of information is helpful in some way or the other. So at least for the example purposes, you may just want to try it out. Okay. So now going on to once you have done the metadata, you look at the different contents of the corpus, right? So there was a command given that you use this method as apply and on your document, and you get the text for each of the documents, and it will give you all this information, like it will give you like document number 1, and it will give you the contents of each and every document here. Because you just give this command here, it just prints out everything that's there in the data frame. So all 18 documents and its description is everything is given here. So write one after the other, as you can see here. Now, besides that, there's another way to do it. You can also there's a command, there's a package called knitr, which is it's got so many things that you can do with knitr, and maybe some of you may have already used it. There's a cable command that you can use it, which helps you to kind of lay out the tables in different forms. So maybe this is something else that you would want to kind of use for printing out information in a tabular form. One more cable. There's something called Pander. Pander is another information. Look at the information that see the difference in information that and how it's just kind of printing it out, right? So based on how you would want to do it, and guys, the reason I'm kind of showing this to you is to not just use it exactly the way it is, but you apply this in the other places as well. See what are the different ways that you could do things. See what additional things you could do for the other steps that are mentioned in there. Is text mining that as I said, is those steps? There are so much more to it, right? So think on those lines, and there's something out there for doing things in a different way, or maybe some other technique, and that's the whole purpose of kind of showing there's different commands to you for the same purpose. I mean, we are not doing anything different here. It's the same output, just a different ways of getting output. So that it could be that think about it at workplace. You take something out there and you show it to your your team, or to your leadership or whoever, and say, oh no, I want it this way. I don't want it this way. I don't like it the way you printed it. Okay, print it in another way. What do you do in that case, right? So there are different ways you can definitely come up with. The same thing here for printing. You've got some options here. All right. So moving along. So then we go on to the data pre-processing. And the first step there was about the remove punctuations. And what it does is, once again, removing punctuation as simple is removing anything in your content that you are taking the entire corpus and you're removing the punctuations. and making sure that it's kind of clean up all the punctuations. And I know one of the questions probably you would be answering here is why do you do that, right? So I'm not going to go into more details, but I hope you kind of have thought about it and also maybe tried with it also at the same time. I mean, if one of the things you want to do is when such a question kind of gets when you are kind of answering those kind of questions, try it out. Try what happens if you retain it, right? What are the when are the times when you retain it or not retain it? What's going to happen, right? What bad things or what good thing is going to happen? So think on those lines, okay? Okay, so I've got a question. How are capital letters handled? Very good question. So here comes the answer very soon. Your question is going to be answered. Just stay with us for like one more step and maybe a couple more, and then you get the answer as to how to deal with the capital letters. Okay, just a couple more steps. So the next here, what it is doing is now. So the punctuations doesn't really and it just goes to the punctuations, comma, semicolon, and quote, a single quote. And so these are like some of the punctuations that it can get rid of, the general ones. But what it does not do, sorry guys, I don't know why I get kind of disconnected from the server. Okay. Okay, but so some of the characters still remain, like you have slash, you have some special characters in there that you would want to remove. So I'm glad that this step was put up as a different as a piece of code that was put up here. This piece of code, guys, is going to be very important. I'm telling you, because this is a simple text. This is a simple text information. I don't know what data set you are working with. But there would be like lots and lots of all these special characters that you will see in your document. Lots of cleaning that you may have to do, and this few commands are going to be so important, and you're really going to be needing it. So whether it's like emails, oh my God, emails. You talk about it, emails. You'll see that there are like tons of these characters, right? You just take any email document. They're like at signs, there's commas, there's dashes. Everything that you can think of, you'll find in an email that you would read from, especially if you're reading it directly from Microsoft Outlook file or something. You'll notice that there's so many special characters that you have to clean it up before you can really make use of those files. So very important, and so I'm glad that this was kind of part of the code or the information that was given to you. So this is cleaning it up. Now look at the metadata. If you have not been paying attention to metadata, then you want to kind of start doing that. Okay, guys. So you happen to see that you cleaned up something, and maybe not here. So you had some metadata information initially, and yeah, if you recall that, initially when we looked at, there was some information about each of the documents. Now look at the information about each of the documents. Maybe remove number 2 here. Maybe look at all the 18 documents. Something changed. Okay. Hint, hint. Now, okay, I'll keep going. Now removing numeric characters. So you remove the. So now you're removing numbers. Now, I don't know, but what do you guys think about removing numbers? Does it really make sense? Why do you remove numbers? I know I don't want to get an answer now. I know this could be once again a question. So really don't want to get into a question, but do you guys agree with removing numbers? What are your thoughts on that? Don't give me an answer about why you want to remove it, but what are your thoughts on removing numbers? Do you think it's an important step? Would you be needing it in each and every text information? What do you lose by removing it? So Jonathan says yes. Anyone else?
Well, it's this particular data set that we're working with. You do need the numbers.
You say you do need the numbers?
I think so.
Okay.
Am I wrong?
Yeah, that's a nice guess. But anyone else who do not agree with that or agree with her? So what would you? I mean, the way you want to think it, and once again, we don't want to kind of get into a lot of big discussion here. But the way you want to think it is by retaining the numbers. Do you get any analysis out of that, right? When you'd go deep into your analysis, where you'd be having different terms. Greg said, yeah, if they would be semantically different, any of the information along with the numbers would make things semantically different. Yeah, I agree, absolutely. If you are able to gather the information and read it, as human beings, yes, I want to see whether this is data 650, data 670. Yes, because I am reading it. But if a machine is reading it, would it? And how are you feeding to the machine, right? If to a machine, is it just going to be a character? Is it just going to be a word, or is it is going to be a data 650? That's important, right? So that's where you want to make a call as to how you are reading your data. That's important, and that's when you kind of answer that question, that would kind of give you, that would kind of help you with whether you would want to retain certain characters or not retain certain characters. So whether it's numbers or anything else also.
Could we convert the numbers to letters? Could we do that instead of,
Yeah, you can, absolutely, you can do that. You can, just use this command here, right? It's a gsub is a substitution, right? You can substitute number 7 with a word 7. You can substitute 8 with a word 8. You can do that. But as I said, like if that's going to give you or help or with your analysis, right? But if they are going to be solitary words just being churned out in your analysis, are they really going to be helpful? What are you going to do with that when you see a word 8 or word 4 or word 6? Is that going to help you? So this is how you would want to kind of, come up with your reasoning why you would want to keep something or change some information in your document. Okay. Converting to lowercase. So this is the answer to the question, what do you do with capital letters, right? Convert it to lowercase. Well, and there's simple commands here. The tm_map is a method that, where you would, well, your one parameter is a corpus, the other parameter is the conversion, right? And the conversion is all these, removing punctuations, removing characters removing numbers, just changing it to lowercase. So this is all changing. Everything gets changed to everything to lowercase. So and then this inspect command is just inspecting the second document. So here in this particular case, I'm just kind of inspecting the same document over and over again, because we are just kind of looking at it and making sure that it's changed. That's the reason why I just took it one document. But you can look at the other documents as well to make sure that it has done what it needs to do. The stop words, right? Stop words is another. It's another very much similar to numbers, right? Whether you want to remove stop words, and how do they help? How they would help? And it's a question, so I'm not going to touch upon that. But this is another thing, which is really on your data set and how it helps or doesn't help. That's how you want to think about it. But this is a way to kind of remove stop words, because they really do not add to much of analysis, or maybe in this case, maybe not. Maybe you'll come up with something, some other, maybe there's some other reasoning for having or not having it, right? But this is one way of kind of doing a stop words on English. You can use stop words for anything that you want. You can add some more words right here. If you see there are names in here that you want to remove, let's say you want to remove UMUC from here, right? Because I just want to take out some of the context from here. and say, okay, just want to remove UMUC wherever it's stamped, you want to remove it. That could be your another stop word along with along with all the other English stop words. So this way you make use of just a single statement here and it so becomes so powerful that you're not just removing stop words, you're also removing other words that you don't need it as part of your analysis. So this is how you want to kind of just try things, or see what are the different parameters to each of these functions. Apply stemming, right? Stemming. So stemming is another thing that where you would want to convert your all your words into the root form, right? And while doing that, it changes. Of course, what's into root form, like like run, running, ran, or run, running. So that could be two words. Let's say you want to just change it to a base, run, right? I mean that's the root form of that. So that's the basic concept of stemming, is to convert all the words into its root form, because it doesn't, when you're doing a solitary word analysis, like a unigram, it's also called the unigram analysis. It doesn't it doesn't matter whether you're using running, word running, or using run, but it would matter if you're using it, like you don't want to see as two different terms. One is run and one is running. Doesn't make sense. You'd want to kind of combine them together, right? So you'd at least know how many times run was used in a word. So that's why the stemming kind of helps you in doing that. Now, something else it does to your text is it also chops off certain. And I know it was mentioned in the document, in the assignment, that it chops off. Sorry, I just missed. Somebody was just typing in something here. From Ben, okay. What if I want to make sure certain word combinations appear together in my analysis, like heat map? That's two words that would be counted separately but have a different meaning when they're together. Excellent question. So yeah, that's a great question, and that's why you would want to kind of take this to a next level of from a unigrams to a bigrams. You can even do like a trigram. You can keep going, right? What would make sense? Whether this unigram analysis would make sense, like you're doing like each word now, and right now you're just kind of doing the cleaning up, so we will not reach there, but very soon we'll be kind of going into creating a document term matrix and going into looking at different words and its frequency, and it's unigram, it's single, right? So the same way we can do it for a bigram analysis, or trigrams, taking two words together. So the answer to your question is yes, absolutely. You can do that kind of analysis, getting the two words together. So either in case I did not repeat the question. The question was, can we take the two words together and if that kind of makes sense, then keeping them separately? Yes, it does, right? I mean that's the whole aspect of this whole new natural language processing, which does even much more than just unigram analysis or bigram analysis. It is going beyond that to see if whether the machines can really read or kind of or go through a documentation, or making sense out of it, right? Maybe in a semantic way, not just syntax or not just frequencies, but something more than that, right? Reading through it and making sense out of it. That's a whole new topic, like a natural language processing, which does that. And you may want to, but still you can take this into another level with your bigram analysis, trigram analysis, and see what you get with that, right? What are the words that come together? What are the words that come together, along with the third word, right? These are the things that you want to see. That's when your analysis is going to go deep, right? What is that the data analytics documents have in common versus what is it different than the other department documents, right? that's what the analysis is really going to. These are the things you want to look for and see if that that helps. And maybe that analysis is going to be like an eye opener. Maybe you'll find out that some documents are written in a particular way, and this is how even people find out whether it's written by a single author or how many authors. It goes to that level of analysis because we kind of go into that depth of finding out like what words, how many words, or what kind of sentences have been used, how many times, and as this goes into like finding out who have been the authors for a particular speech or a particular article and all that. So, but yes, that's a whole new topic, but it's interesting, very interesting, and that's what I'm kind of trying to get you all into, kind of at least kind of showing you the way to kind of getting deeper into this, and don't just stick to the basics here. This is just the starting point. So Professor Gorcheva and Professor Dave have really given me a good start here. So just work on it and take it to the next level. Take it as far as you can, because you would get into very soon into other assignments and to Watson Analytics, your group project, and you'll need all this information. You'll need to kind of go deeper into many different aspects. You'll also be very soon like going to the next course. You'll be doing it all by yourself, a whole analysis. Why you're doing this? Why are you just comparing documents here? Why are you taking a data set? Why are you taking all the emails and what are you trying to do with it? So, oops. Okay. Any questions? Any other questions? Okay. So moving along. So this is the frequency. I hope there's not much. I think this could be probably self-explanatory that once you've done removed all the things from the corpus, you created a document term matrix, which is just putting it in a matrix form, and once again just giving you some information, and you go into frequencies. Okay, so the frequencies here, it's just giving you like the frequency of each term. How many terms did you find? Look at the order. Just try to set them in an order. Look at the dimensions. 18 documents, 411 terms, right? So that's what I got. Like maybe it would be different if there's like a different, and sometimes there could be a little difference of what you get versus the other. But I think what you want to follow is the right method, right methodology, and see if there's anything that you may have added or if there's an error. But otherwise, there could be at times a little bit of difference here. But yeah, in this case, you are just kind of printing everything out here, and yeah, look at this information. So there's a document. This is all character zeros. Okay, and these are all the terms. So from the numbers, yeah, I could say that this is document 1 through 6, and same way here, I could say these are all 7 through 12, and 13 through 18, all the documents here with all the different terms. Of course, there was like 411, but due to space constraints, did not go through and print all of that. Okay, then there's terms with minimum frequency. So you can just change the frequency to whichever you want and see what is the frequency. Okay, you set it to 5, at least 5. What if it is if you increase it to 6, right? You increase it to 7. What happens, right? How many words are there with minimum 7, with 8, right? With 9? Well, what does your word terms list go down to? Or what happens if you just decrease it and go from 5 to 4 to 3? How does it kind of increase? So what has been your average kind of a frequency of words per document, right? I mean, something to think about. How is this changing? What is the rate of change from one frequency to another frequency? maybe of importance, may not be of importance, right? I mean, it's not really that you should be doing it. I'm just saying that these are the things you want to kind of start thinking about, and if there's a change, maybe that change is really going to help you. That rate of change is kind of saying you something. Maybe you want to catch on to that. Sparsity. Yeah, this is another area where you kind of make a judgment call on whether you want to remove the sparse terms which are in not there in 70% of the documents, or you want to do it more. Maybe if you want to say that you want to increase it to 80 or increase it to 90, and then you have more terms, or do you want to go with less terms, right? For associations, if you are associating these 4 words and seeing if the limits with with these 4 words, what is at least the correlation to be at least of 7.5, you get all these words. What if I set it to less than that, right? What happens with 57, right? Or maybe even less than that. So, see this, it kind of changes. You get some more words here. Or if I change it to, maybe with 80%, 83%, right? Or 0.83. Data does not have any word with that kind of correlation. Analysis doesn't have. Methods have, and mining have, right? So this way you kind of get to know, like by looking at all these by changing these numbers, by changing some of the words, you are getting some information that will be required, that will be helpful. Okay. Then you have the term plots, right? I mean, you saw that you would not at least see it in a text form. You can put what you just saw in a text form. You can put it in a graphical form here, and you can look at all the correlated terms. Like in this case, you are taking frequent terms, and you're taking at least of frequency 5, and you're taking in only 10 words because once again for the space constraints. You can go with more. You can play with more, and with the threshold of 50% or 0.5, and you can keep playing with the threshold. See what threshold does make sense, right? 50% or maybe less than that. What happens when you take it to 21 or 20? You see that the relationships, it kind of shows more than what you had seen before with 50% or 0.5, sorry. So this is how you want to kind of just change and play with it. Now there's also another way of looking at the same information, which is this correlated terms weighted lines, right? So in this particular chart, the strength of the lines, the darker they are, the more the bigger the relationship is. Now look at this. If you change it, it just shows you exactly the same way what you've seen before. Now along with the lines, now you kind of also see what is the strength of relationship. Okay, so this is kind of seeing your data in many different ways, and not just different ways, but also by changing certain parameters, by certain thresholds, you can try to analyze it and then see what kind of makes sense and what you're really looking for, and what was something that you are not really looking for but you found it, right? That's also going to be important. Then there's this bar plot of all the words, all the words, but the words, like in this case, we are just building it for frequency, which is having at least 5. So this is what it's doing, creating a word frame and putting it in a ggplot. So in this case, you're using a package called ggplot2, which has got, so ggplot is once again one of the nice graphical packages. So besides the base that you have, like the basic, the base one, and then there's lattice. That's 2 graphical environments that you have. ggplot is another one, which is kind of popular because of the way that you can come up with real fancy plots and nice, even more colorful than what you see here. So yeah, I mean, because once again, there's so many parameters to ggplot that you can just change this whole plot into, into really colorful, or many different ways you can change this plot. So yeah, I mean that's the other thing, that you can play with all these different commands. So here once again, once you change it from 5 to, let's say you want to look at everything that's up to 9, you see the different words, right? So now you know that, with the frequency greater than 9, so which is at least 10, what are the different words out there? So these are the words that have been used kind of heavily, right? At least these are from the sparsity that you picked on earlier. Maybe with the sparsity that, if you go on to, decrease it or lower it, play with it and see what changes you get. And then, you have, so now once you've kind of done that, you're almost towards the end, guys. So just, couple more items and then we'll be done. But let me just, ask you again, any questions based on what we have gone through so far? Does this help? Is there any question that remains unanswered? I mean, this is the time, folks. I mean, if there's anything that you have in your mind about R, or whether it's just particular exercise, or maybe that it would be a general question, it will help others as well. This is the time. I mean, you really don't have to go through this or all these, the steps that you've already got in your Word document. It's just kind of laying it out in a different form here and maybe showing it in a couple of different ways. We don't have to really spend time on that. We can spend time on any questions that are on your mind. That's more important. So we still have some time to, kind of go through your questions. So if you have it, please, please go ahead with it, okay? Anyway, so if no questions at this point, so I'll kind of keep going and finish this last piece of it, which is clustering. So clustering is, as you may have already, done it in of course, previously the unsupervised part of, machine learning, where, you would kind of try to put all the different terms or different words into different clusters, right? And try to see what clusters or how many clusters do you get, right? So one of the ways is the hierarchical clustering, and you might have to kind of course read on hierarchical clustering, and it kind of so in this case you kind of first of all you want to prep. In the prepping was in this case we went from 70% removal of sparse terms to 80% removal of sparse terms. So kind of getting some more words. As you can see here, we went from almost 20 plus kind of 20 odd words to 39 words, kind of added some words here. So we got that kind of a data term, our matrix here, and then so the document term matrix, and then based on that we do the next step of creating this the distance matrix or the dissimilarity structure. And so what it does, it's doing a transpose, which is nothing but it is converting to almost like it's converting to a term document matrix. And the method for the distance computation, it is using the Euclidean method, and it creates this dissimilarity structure. And this is kind of also the clust command that's being used with the word T2, and once that's done, the clusters, so it gives you all this information here with the fit command, right? And so how does this really help? I mean, yeah, this is just giving you some information. You created a distance matrix, you created a dissimilarity structure, and then how does it really help? So now when you plot this, that's the beauty of a dendrogram. When you plot this hierarchical clustering technique, it gives you all these different groups of the terms, and then you find out how many clusters really would make sense, right? And do you guys know, and does anyone know how to, by just looking at this structure here, how many clusters really you should form? Does anyone know? If not, that's okay, guys. I mean, absolutely fine. Don't want to put anyone on the spot here, but the thing to kind of, you want to kind of look into that. You want to really know from this, the one of the things that, kind of comes up in hierarchical clustering, and any clustering technique or form is the number of clusters, right? Whether it's k-means, whether it's cluster, and we'll talk about that soon. It's about the number of clusters. How do you find number of clusters here in a dendrogram, right? And without going through anything right now, how would you just figure it out, right? What will be the technique that you'd use to find out how many clusters are there? If not, go read it. Elbow plot, yes, that's the elbow plot is there. If I don't have an elbow plot, without the elbow plot, can you find out the number of clusters? There's a very simple technique. Very simple technique. Take that as a homework. Take that as an homework assignment, guys. I'm telling you this. And when you find out, it's interesting. When you find out, you really apply that and compare it with your elbow plot. That could be another technique for you. Okay. But there's a very simple technique to find out from an hierarchical cluster how many clusters are there. Maybe it may not be, once again, like elbow plot or any other techniques for finding out your number of clusters or K. This is not going to be like a solid, very concrete K, but at least giving you a very close, and it gives you a very close number of clusters. As a matter of fact, this simple technique is sometimes much more powerful than your scree plots. I mean, at least that's what I found, that it's really helpful. Okay, so find out. I'm sure there's information about that, and you'll be able to find it out for sure. But in any case, okay, oh, maybe I missed that. So let me go back. So that's this dendrogram with clusters, and the way you kind of did that was you grouped it, you cut the tree, and using with the K equal to 4, indicating that you want to cut into 4 clusters, and this is how and there's a rectangular shaped structure that or a rectangle that's being created or being dropped on this particular dendrogram. So you see that this is 1, 2, 3, and 4 clusters it formed. Okay. All right. Any questions? Okay. So once again, for the k-means, we are doing the prep here, changing the sparsity to 75. Once again, you can just play with this. What sparsity you want, you can go with it, depending on the documents and the number of terms, and of course the computing power that you have. That's also going to be important, and you get a different cluster plot. So same technique. So you're going through finding out D. You go through k-means, and here is, you notice you have to give this clustering algorithms. You have to give the K, right? So many a times it's like, okay, I give some number and then I find out how many clusters that I should make, really. But that's how the technique. There's no solid technique. There are different techniques, of course, but no solid technique to kind of say that this is the technique and this is the only way to kind of find out about clusters. So that's one thing about these about clustering and the clustering algorithms, that about this finding out about K, and sometimes it's also about visualizing it. So showing you different ways here, like the clusters. This is one way to an hierarchical cluster would be one cluster plot. You want to see the same, maybe the same sparsity, same data. How does it look like in a cluster plot with 3 or 4 clusters? How does it look like with 3 clusters, right? Does it really make sense? Does it really group them well with 3 clusters versus 4? So it's art and science, not completely science, guys. I mean, yes, this all data analytics is yes, there's a lot of science involved, a lot of techniques, a lot of statistics involved, but there's some art involved as well. And that's why we kind of rely on a lot of visualization, because you're going to make certain decisions, certain things may change based on what you visually see or what applies to your domain, your business domain that you're working on. So that's why I kind of say it's an that, and it's also being said that it's an art and science. And yes, someone mentioned that about the elbow plot, just right. Yes, this is one of the techniques, one of the popular techniques. Let me put it this way. Yes, this is a very popular technique to get the value of K and apply that to your clusters. Once again, this is by no means it's a foolproof method, but it gets you to very close. Like you won't get always a structure that would give you a distinct elbow and say, yes, this is a distinct elbow. Okay, use that in a point where there's elbow. What if you get just a very smooth line, like going from the top to the bottom? You'll see that. You've seen some of the data set that you use, or some of the ways that you would get to that kind of a structure or a plot where you'd be like, scratching your head as to what K value should I pick, whether it's 4 or 3 or 2, what it is, right? And that's when you will have to make a judgment call, right? Or maybe you have to try with these different numbers to kind of come up with the best value of K. But in some cases, yes, we can make out here in the elbow, and sometimes even that the elbow is not very clear whether this elbow is 3 or whether it's 4, right? How do we make that out, right? So one of the things that at least how I learned it was, yes, there's an elbow. If there's a distinct elbow, fine. But if there's like a little confusion like this over here, right? I at least I got confused with this one here, 3 and 4, right? And that's why I would want to try with both 3 and 4. But in this case here, look at this. I mean, if this is the pattern here, and if I have to draw a smooth line, it would basically just cut, or it will not include this number 4. If I have to draw a smooth line, I would go around number 4 here, this dot here. So that gives an indication that your K value of 4 is correct, right? Because this smooth line is not passing through 4. So this 4 is outside of that, this pattern here, outside of that line here. So this is where it's kind of breaking the trend, the line, and this would be your your breaking point, your elbow point. Okay. Any questions? You guys are quiet, maybe getting tired, but we are there. We are there. Just one more thing, and we'll just wrap this up. Okay. But I hope this was helpful. So just added one more topic here. As I said, you want to kind of add always to add to what has been given to you, or in this case there are already some prepared statements, prepared information to you. How could you add it, right? This is one of the areas. Topic modeling by itself is a huge area. It's a subject of its own, and spending 5 minutes, 10 minutes is not doing justice to it. But at least it's one of the ways that you would want to find out, and it's one of the I think one of the powerful ways to kind of also find out different topics. It's been used in many of our text analysis, especially when you are analyzing your emails, your books, your speeches, and conversations, or customer complaints. Topic modeling becomes very important. And topic modeling really is not semantically giving you topics, but we'll go through. But it's very similar to clustering, right? What you did with clustering is forming the group of words that may be going together. It's a similar concept here of using a different kind of algorithm, a different package called topic models. And in this case, what you're doing is making sure that you are all taking in only those rows that have at least one particular term. So that's why you're doing this row sum here, which is kind of making sure that the sum of each row of the sparse DTM is at least 1. The document that is contained in this matrix is having at least one term in it. It's just kind of making sure. So That's what it does here. So once you've gone through that, you have kind of gone through the preparation step, and then you go through the LDA. So it's using latent Dirichlet allocation. Latent because the topics are kind of hidden, you don't know. Dirichlet because it's using the Dirichlet distribution. And oops, come on, I don't know why this keeps disconnecting today. Although I've been playing with it, but anyways, we are just at the last part here. So let me use the menu here. Okay, so yeah, it's using the Dirichlet, as I said, it's using the Dirichlet distribution, which is kind of it's using this distribution because it is less computing and intensive, and it's it's kind of very useful for doing the text topic modeling, and it's kind of more precise than the other methods, algorithms that could be used for topic modeling. So that's why kind of using this kind of a distribution. So it's doing very similar to what you did for clustering, like you call this function and you give in your data term matrix. You have to give value of k as usual. Many times, if you know the topics, you know that this consists of information of 5 players, 5 basketball players, or 5 baseball players. Maybe I know the topics. Oh, this particular text information has got people talking about sports, politics, about movies, about TV. Maybe I know about 4 topics that are in this particular information. Then I know the information and I go with it. So that's the basic assumption that of LDA, that you would know this, the number of topics, and you would send, because it is really not giving any semantic information, as you would see see going further, that it's not giving you it doesn't know by itself that, hey, this information that you provided, they're all talking about sports. It's not going to tell you that, or they are all talking about politics. Sorry, it's not going to tell you that, because it doesn't know the semantics. It just knows that there are certain words that kind of go together, and they've been already that the document was formed, or certain documents were created based on that collection. So when you see that the topics, it comes up with different words in each topic. So it says topic terms, and you can get the first 5 terms of every topic. So this is the command that you give, and then you print it out. Very likely that some of the words would be in more than one topic. It's quite likely. But the combination of all these words, maybe these 5 words will not really make a lot of sense, but maybe when you look at 10 or maybe more at sometimes, then it would give you an idea of what is the theme for these different words put together. Like, I think I've probably used particular names for some of the for these topics later on. I think the next tab there, I've kind of used certain topics, but this is how you kind of you can see these different words. Maybe these topics, you can name them based on the different words. So let's see what we kind of come up with. So then we also want to find out about get one topic for each for each of the documents. Let me change that. But for one of the documents, we want to kind of get the topics and the frequency of the topic. So what happens here? So it shows for each topic and for each particular note, and for each the topic frequency. Sorry, topic frequency for the document. So for the document number 1, the topic is 1, and the frequency of that particular topic is 7. So that's the frequency of that particular topic that was in that document number 1. Document number 2 had the topic 5 being with the frequency of 27. So that's what you will see here. Now a bar plot could also be created, very similar, like what are the different topics and how many times do they occur. So this is the bar plot that you would create and see which topic. Now at this, I think it's this one here that I commented that, how about topic 1 to be concepts, topic 2 to be performance, topic 3, it's about tools and techniques. So you can, looking at the different combination of words, you can try to assign some name or some theme to this, okay? So that's about, the topics. And then there's one more plot. You look at like it's a density plot that you can look at for, the same topics, but in a different way. Like you look at the total terms and the different documents, documents covered by each topic, and see as to what's the kind of coverage of each document and different terms in topics. So again, this is another way to kind of look at it. But yeah, I know spending 5 or 7 minutes on this topic is really not justified at all. It's, as I said, it's a huge topic, and a lot of information you can get. Maybe you can do more precise and get some more information out of it, and by playing along with different parameters, a number of topics. So all the same thing, same aspects that we kind of covered while clustering. Okay, so that's all kind of wanted to cover. So kind of let me open it up for your questions again, and then see if there's anything that you would want me to repeat, or if there is anything else outside of this.
No, this has been really helpful. Thank you.
Thank you. By the way, just one more thing, in case you'd be interested, this whole presentation is written in R. So what you see here is the power of R. So that's how the R is so it's kind of just not just powerful, but and that's the other thing I wanted to show you. Kind of this is kind of taking it to the next level. That you can do all this in R, and not just the HTMLs. You can do presentations, multiple things that can be possible, and you want to kind of get to that point, and I'm sure you will with all the information that you have, and with so many different feature set that that R has now. I'm sure you'll be able to get that. So try different things. Don't be afraid. Nothing's going to break. Even if it breaks, you can always bring it back. Of course, make sure that you copy your programs or anything in a safe place, so that it breaks any time. You have it somewhere as a backup. So always keep taking backups, but don't be afraid to to practice or try anything new. It's always going to be helpful. There's things out there. There are features out there that you just don't want to kind of keep saying for months and years that I really don't know what that option is doing or what that feature is doing, because yeah, there could be something that could be very helpful to you. And if you have these techniques, maybe there's techniques. The reason I mentioned this is also the fact that instead of writing so many lines of code and trying this and changing this, if you had something like this, like a slider, you could just slide things and keep seeing what changes it's making, right? You didn't have to. You'd have to just spend time on just putting this up very quickly, and that too maybe the first time there would be a little struggle. There would be little learning session, like you'll have to like a ramp up time. But once you kind of gone through the learning curve, it becomes easier, and you would spend less time on trying to find out what is the best value of threshold, what is the best value of K, what is the best frequency that I want to show. All those answers, you could get that from just by using some of these widgets here, by some of the visuals here, and that would make life easier, and also your analysis easier at the same time in a shorter period of time. Okay. All right. So any other questions before we wrap up? So I'll send this out to you. This will come into this may not be like interactive as what you see here, but at least it will come to you in a PDF form. And everything that you see, even with the tabs, they will be kind of expanded, and you'll get like a huge document. But it will cover everything that that you saw today. Okay, so just go over it and maybe just, as I said, there's nothing new or as we covered, maybe certain things that could be done in different ways. Topic wise, we only covered topic modeling little as something that wasn't part of the Word document, but other than that, everything is in that Word document. So go through it, and if there's any other questions, let us know. Okay. So if no other questions, we can call it a wrap. Yelena, you have anything else to kind of add or say?
I think this was very helpful, as that was an outstanding presentation.
Thank you. Okay, so let me stop sharing and
I guess
stop recording.
I'm stopping it now.
Oh, yeah, okay.
Thank you so much. Thank you.